Good morning, everyone. My name is Althea Sungahid, and together with my groupmates, Dave Hart Sayagnon and Maryjoy Asilan, we are going to present to you our simulation project proposal about waves on a string. Waves are disturbances in a medium that carries energy without a net movement of particles. It may take the form of elastic deformation, a variation of pressure, electric or magnetic intensity, electric potential, or temperature. It was said to have the capacity to transfer energy, usually involves a periodic, repetitive movement, and lastly does not result in a net movement of the medium or particles in the medium, unlike the mechanical wave. Moreover, waves have different types according to their area of study, namely are the following together with their definitions. Number 1. Transverse waves. Waves in which the medium moves at the right angles to the direction of the wave. Example of these waves are water waves, light waves, S-wave earthquake waves, string instrument, and torsion wave. Second, we have the longitudinal wave. It is a wave that has the movement of the particles in the medium in the same direction as the direction of movement of the wave. Examples are sound waves, P-type. Basic concepts, properties of waves. First, we have the amplitude. Amplitude is also called as the height of the wave, usually measured in meters. It is directly related to the amount of energy carried by a wave. Wavelength. The distance between identical points in the adjacent cycles of crests of a wave is called a wavelength. It is also measured in meters. Next is period. The period of a wave is the time for a particle on a medium to make one complete vibrational cycle. As the period is time, hence, is measured in unit of time such as seconds or minutes. Frequency. The frequency of a wave is the number of waves passing a point in a certain time. The unit of frequency is hertz, which is equal to 1 wave per second. Next is speed. The speed of an object means how fast an object moves and is usually expressed as the distance traveled per time of travel. The speed of a wave refers to the distance traveled by a given point on the wave. Crest is a given interval of time. Damping. In physics, it is the restraining of vibratory motion, such as mechanical acceleration, noise, and alternating electric currents by dissipation of energy.
Activity Procedures Part 1. First, open the waves on a string simulation from PhET. Second, set the damping to 0. Third, change the setting to oscillate rather than a manual. Choose no end rather than a fixed end, and then set tension to high, and lastly, check the ruler and timer boxes. Things that you need to remember. First, do not change the amplitude or tension setting during the experiment. Second, leave the damping set at 0. Third, use the ruler to measure the wavelength of your wave in meters. To accomplish this, it works best if you pause the wave motion to get your measurement, then drag the ruler to move. Fourth, for 5 different frequencies, measure the wavelength of the wave produced, and then record the frequencies and wavelength in a table.
Introduction of the simulation. Wave on a string simulates the motion of a vibrating string as well as ideas for activities involving the simulation. The end of the string can be moved using the mouse or driven by an oscillator to set up traveling or standing waves. The string is modeled as a series of interacting masses. The tension of the string, damping, frequency, and amplitude of the oscillator can be adjusted. Measurements can be made with rulers and a stopwatch. So this will be the representation of the given procedure. This will be the setup in which you are going to perform the simulation. And with the help of rulers and the timer as well as the reference line, you can find or you can measure the wave speed. You can also find the frequency and the amplitude and also the wavelength of the wave. These are the related formula in the simulations. In finding the wave speed, we have two formulas. One is S is equal to the frequency multiplied by wavelength, or that is hertz, multiplied by meters. Next, we have the wave speed is equals to the distance covered over time taken, or S is equals to d over t. We also have the formula in finding the value of frequency when the period is given. F is equals to 1 over period. And to find the value of the period when the frequency is given, we have this formula. Period is equals to 1 frequency. That would be all. Thank you and have a good day.